Welcome to part 3 of the Ripple Water shader tutorial. In the previous part we have made this scene where balls can hit the water and a ripple is instantiated at that position. Now what we're going to do in this last part is we will calculate a distance spread. So at the point of collision it will calculate from that moment on. It will widen a certain distance, so it will spread like a natural way and not affect the whole plane. So let's do that. So we're going over to our script. We had our C# script here, but I'm going to the shader and we're going to add some more floats here to affect this impact, what we want to do. So let's start off with float, and I will call this distance, and I'll do the same for what we've done before. Distance 1, distance 2, and I don't want to type it all, so let's just copy paste 4, 5, 6, 7, 8, and I'll change the numbers again. 3, 4, 5, 6, 7, and 8. And what we also need is an impact position. So I'll call this X impact 1 and Z impact 1. Now we'll copy this again, and we have to do that for all of them. So this is 2, 3, 4, 5, 6, 7, 8. So we'll make this 2, 3, 4, 5, 7, and the last one 8. Don't be afraid, these were all the variables. We don't need any more of these in the shader. Now we still have to set these floats up in our script here, but before I'm going to do that, I'll save this one and let's go over to the C# so I can explain why we set up these different floats. So here in our C# script we're going to add also a few more variables. So I'll add a public factor 2, which has an X and a Y, but for our purpose it's an X and a Z. So this is a array, and I'll call this impact position, impact pos. And we'll also need a public float array, which is called distance. So basically what we are going to do is we have our impact position of the position of the object that hits the plane, and these positions we use as the center point from which we want to calculate a distance outwards. So this number is going to be bigger over time, and the wave will spread inwards out to affect more vertex points. So let's set this up and go to our onCollision enter, and we want to adjust some things in here. The first things we're going to do is reset the distance to 0, as we did with the wave amplitude. So we'll say distance, where we will get the wave number -1 is 0. And now at the point of collision we want to set the impact position to the transform position of the plane or the ball that hits the plane. So we will type here the impact pos with again the wave number -1 dot its x is call dot transform dot position dot x. And for the other one, because it's a factor 2, so we've got here the wave number again -1 dot its, and you would expect to have a z here now, but you have to get the y, and we have to call dot transform dot position, and this is important, this is the z, so its y is going to be the z. Now we head over to here, and we can set the renderer dot material dot set float of the x impact plus wave number is the call dot transform dot position dot x, and the same goes for the z, and it's the z. Now heading over to our for loop. So if the wave amplitude is above 0, then we want to increase the distance over the time. So we'll say distance y plus is a certain number. So we can make a new public float. So I'll call this public float speed wave spread. So I will take this and put this here, and we can fill in the speed of how fast the wave is going to be shown, and how fast the vertices are going to be affected by the shader of the ripple effect. And also, if the wave amplitude is 0, then the distance should be 0 too. So I'll type in here distance is 0, and let me make this a little bit smaller so that'll work too. Now we need to still set the renderer of the shader of its distance to distance. So we'll type in renderer dot material dot set float, and we'll get here distance that we set in our shader plus I plus 1 is going to be distance and there you go. Now if I'll save the script, let's see if it works. Go over to Unity. Oh, I've did something wrong in the shader. So let's go over to the shader, and I forgot here to make a semicolon. So let's save that. Let's head back over. Yep, it works again. Now for this to work, we still have to make a few changes to the shader. So let's head over to our shader, and we have to do the distance check. And as the vertexes are in local space and not in world space, but the data that I'm getting into the impact is in world space, we want to make a new float tree actually of the vertices in a world space. So we're going to convert the vertices. So I'll type in here float 3 world pos, I'll just call it world pos, is a multi-mule of we can just say here object to world, so it'll put it into world space. And what has to be put into world space? It's the v.vertex dot its x, y, and z. And now we've got a world pulse with x, y, z values that are in world space, and these are the vertices. So now I've got a whole list of these offsets on the vertices here, and I'm going to put an if statement around every one of these two. And in these if statements we're going to check the distance between the impact position and the distance number that we are getting into these values. So if you want to make a distance check, normally in C# of Unity you can say vector3 the distance, but you can't do that into this shader. So to get a distance we have to take a square root of its x value in the power of 2 plus the z value in the power of 2. So we'll type that out. So let's start off with an if statement. If we can type square root of power of world pos dot its x minus the x impact 1, because this is about the first one and we have to do this for 8 different, and it's going to be in the power of 2. So that's for that one, plus the power of world pos dot z minus z impact 1 to the power of 2. And forgive me if I make a mistake here, and if it's smaller than distance 1, because distance is going to be a number that's in the beginning it's set as 0, but every frame rate the distance is going up a little bit. So, and that's what we did in our C# script. So this number is getting higher and higher at the point of impact, and every time that we get the impact position of its x and z. So if this position is having a distance from its center point to this value, then it's going to be bigger. So it's spread like a round wave. So let me just open this one, and I'll put these two in between there. And I already made a typo here because there's got to be one more bracket here. And now we can just copy these for every part here. So copy this here, close it, copy this there, 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 so I'll just put it around every one of those, and we have to close them to all. So that one's already closed, but this one isn't, so closing number 3, number 4, 5, and number 8. Yep. And now that we've done that, now we have to still change these numbers all, these, because here we've got this is number 2, number 2, number 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 6, and 7, 8, 7, 8, 7, and 8. So let's save the script and see if I get any errors. No errors, so it'll work. But what we still have to declare here is the public arrays, because I made them public, so you have to type in 8. You can actually make them private too, then you wouldn't have to do this, but I'd like to see an overview of what's happening with the numbers. Speed, wave, spread, we also have to declare, because otherwise the distance won't become any higher. So let me set this to 2, and if we've set up all the numbers correctly, then we can try it out. Well, let's try out. Look, it is working, but it's going a bit fast. So maybe if I put the speed of this to 0.2, to like 1. Yep, this looks pretty much okay. I think we can adjust some numbers of the ripple effect a little bit, but it works. So I'll set this to 1 for now, and let's check out again. I will configure the frequency a little bit. Maybe speed. And maybe the speed set to 0.5. Well, as you can see, it works, but it's still a bit of tweaking around. Now, if you would like to see these waves, but also see a wave all the time, you could do that very easily. And you can go to here. You've got all the if statements. But what you could actually do is we have set here an offset. So let's copy this, and let's say offsetvert2 is like vertex.x plus vertex.z. So in the start of this tutorial, you've seen that this will create a diagonal wave effect. So what we could do is set this. We could get here a value, and I'll copy paste this, maybe a little enter between, and I'll make this value 0, and I'll do this offsetvert2, and I'll remove this whole thing. So now we've got a value 0 here, and if we would go outside of the if statements and just type in v.vertex.x, y plus is value 0. So this will always be there. Let's also get the normals of it. And now we have a wave that's constantly there. So here you can see the final result of our tutorial. You'll see the diagonal waves, including the ripple water effect of impact positions of the ball. This comes to the end of the whole tutorial. It was a pretty long one, but I hope you liked it. And if you liked it, then please leave a comment on this video or check out my website peerplay.nl, so you can check out the games I'm making or any other tutorials. And it was my pleasure to give you this tutorial, and see you next time.